This is a review for sections 3.1 to 3.2, which covers parallel lines, transversals, and angles. First off, we have parallel lines. Parallel lines are coplanar lines that never intersect. Here's a quick example. We have one line, and we're just going to simply duplicate it, which means that it's as the same angle as this one. And now you can see these are both parallel because they will never intersect each other. Next, we have skew lines. These are lines that do not intersect and are also not coplanar. In this image, an example of skew lines would be line WP and line RY because they will never intersect and they're also not on the same plane. Simple enough. Here we have transversal lines. A transversal line is a line that intersects two or more lines in a plane but at different points. The transversal line in this example is obviously A and B because it intersects EF and CD. Now I'm going to walk you through transversal angles. As you can see, we've named each of these 8 angles. The exterior angles of this transversal figure would be 1, 2, and 4 and 8. It's 1, 2, 4, and 8 because, or 1, 2, 7, 8, excuse me, because they're all on the outside or the exterior of the figure. The interior angles would be 3, 4, and 5, and 6, simply because they're on the inside of the figure. Consecutive interior angles, 3, 5, and 4, 6. Consecutive interior means that they're simply on the interior and they're on the same side. Alternate exterior angles would be 1 and 8 and 2 and 7. This is because they are the exterior on the outside, and alternate means that you've crossed the line, which you see we can do with 1 and 8 and 2 and 7. Alternate interior angles would be 3, 6, 4, 5. This is because they're alternate, which means you cross the line, and interior means on the inside of the figure. Corresponding angles, examples are 1, 5, 2, 6, 3, 7, 4, and 8. Corresponding just means that they are on the same side and they're equal to each other. As you can see, 5 and 1 are equal because they are corresponding. Vertical angles are next. Examples are 1, 4, 2, 3, 5, 8, 6, and 7. Vertical angles just means that it is the angle that is opposite of one angle and also means they're equal to each other. Linear pair means that two angles equal 180 degrees. Example would be 1, 2, 3, 4. 1, 2 because they equal 180 degrees. Same with 3, 4. And we have 5, 6, and 7, 8 are also all linear pairs. You could even go 3 and 1 and 4 and 2 because they're still on the same line and they equal 180 degrees together. Postulate 3.1. If two parallel lines are cut by a transversal, each pair of corresponding angles is congruent. That means that, like we said earlier, the congruent angles 1, 5, 2, 6 are equal because these lines are parallel and it has a transversal going through it. And these are the same thing as earlier as we showed you. And I'm going to walk you through all of the angles that are equal to each other. First, we have alternate exterior. So you can see 1 and 8 are alternate exterior and they're equal to each other. Next, we have alternate interior. 3, 6, 4, 5. Those are both equal to each other. Next, and finally, we have vertical angles. Example would be 1 and 4 and 2 and 3. They are also equal to each other. So these 4 right here, all these angles equal each other. Next, we have a couple practice problems from the simple things we did earlier. First, we're going to look for the figure that has parallel lines. In this example, it's rather easy because, as you can see in this one, we have two lines that look parallel, but the dead giveaway is that these two lines both have an arrow going through it. And if you ever see that, that means that the two lines are parallel. So we can go ahead and move this above here. Next, we're going to look for the figure with skew lines. Skew lines means that the lines never intersect or are on the same plane. These lines obviously intersect right here, so we know it's not that, and so we take a look at this figure, and an example in here would be BH and DF. They are skew lines because they're not on the same plane and they don't intersect. And then finally we just have this figure left. We know that transversal lines from earlier have one line that crosses two lines at two different points, and so we can go ahead and drag this above here. In this example, we're going to name an angular pair of angles for each term, and we can just do one for each. Exterior, we know that exterior means that the angle's on the outside of the figure, so we can go with the basic one and choose angle 1. Interior no means that the angle is on the inside of the figure. We can pick angle 3. Consecutive interior means that we have two angles on the same side and they're not crossing each other, and interior means that they're on the inside this time. We could pick 3 and 5 would be an example of a consecutive interior pair. Alternate exterior, we know that exterior means they're on the outside of the figure, so it has to be 1 and 2 and 7 and 8. We have to pick from there, and then alternate means you cross the line. So for this example we'll choose 1 because it's on the exterior, and also because 1 and 8 are alternate exterior because it crosses the line as well. Alternate interior, we know interior means it's one of these 4 because it's on the inside, and alternate means it crosses the line. For this example we'll pick 3 and 6. For corresponding angles, we know that it's on the same side and they're equal to each other. So we know that 3 and 5 aren't equal because they are same side interior, and those are not equal, so we'll go with 1 and 5 are the corresponding angles, along with other examples like 2 and 6 and 3 and 7 like we covered earlier. Vertical angles, one example we can pick would be simply 1 and 4 because they are equal to each other and they are simply opposite of each other, as you can see 1 and 4 are. Finally, we're going to look for a linear pair. Linear pair means that the angles are 180 degrees when they're added up together and that they're on the same line. Not necessarily on the same line, but for this example we'll say we're on the same line. We can simply go with 5 and 6 because they're on the same line, and together we know that they equal 180 degrees. Now we're going to use what we just did and what we learned earlier about which angles are equal to each other and which ones are supplementary, which means they equal 180 degrees. So find the measure of each angle by using this measure, 58 degrees, which is given. So we know we have 58 degrees. We'll start simply with angle 5. Angle 5 is a linear pair to 58 degrees, and so we will take 180 minus 58, which will give us what 5 is, because like I said, they're a linear pair, and 180 minus 58 is 122. Now that we have 5, we will use what we learned earlier about corresponding angles and go up and find angle 1. We know that corresponding angles are equal to each other, so we know that 5 and 1 are equal, so we can also choose 1 as 122 degrees. Next, we'll go with another linear pair, and because 1 is a linear pair with 2, we know that to figure out 2, you have to take 180 minus angle 1, which is 122 degrees, which will equal angle 2, and that also equals 58. Next, we'll use vertical angles to figure out angle 3. We know that 2 and 3 are vertical angles because they're opposite each other, and we know that vertical angles equal each other, so 3 also equals 58. We will also use vertical angles for angle 4. We know that 1 and 4 are vertical angles because they're opposite each other, so 4 is also 122 degrees. Next, we'll move down to 7. We know that this angle right here, which is 58 degrees, and 7 are vertical angles, so we can say that 7 is 58 degrees because vertical angles equal each other. Next, we have angle 8. We know that 7 and 8 are not corresponding, they're a linear pair. So to find 8, we take 180 degrees minus 7. We know that 7 is 58, and that equals 122 degrees as well. We could also use 8 and 5 as a vertical pair for vertical angles. Figure that one out. Next, we have theorem 3.4. In a plane, if a line is perpendicular to one of the two lines, then it is perpendicular to the other. And this means one of the two parallel lines. But you can see that 2 and 3 are parallel in this example because of these two arrows that tell us that they're parallel. Alright, so we know that 1 and 2 are perpendicular because we have the perpendicular sign right here. So using this theorem, we're going to move on to the little tougher step and actually figure out a proof using this theorem. Okay, we've got theorem 3.4, remember from earlier. Prove that angle B is perpendicular to line 3. Or not prove that angle B, prove that line 1 is perpendicular to line 3. Alright. Okay, so we've got the given. We know that 2 is parallel to line 3. We know that 1 is perpendicular to line 2. Next step is to say that angle A equals 90 degrees. And that is because of the definition of perpendicular lines. Next, we can say that the measure of angle 1, or that A equals a right angle because of the definition of, because we know the angle A is already 90 degrees. Kind of repetitive, but still need to put it in there. Next, we can say that angle A equals angle B. You can see A and B right here, and they equal each other because they are because of the definition of corresponding angles. Next, we can say that the measure of angle A equals the measure of angle B. And this is because of the definition of congruent angles. Because A and B are congruent because they're corresponding, which means they're equal to each other. The next step is to say that angle B equals 90 degrees as well, because as you can see in the corresponding angles, A and B equal each other, and A is 90, which means B is also 90. So we can use the same def of corresponding angles. The second to last step is to say that angle B equals a right angle, simply because of the definition of right angles. And I know this is all kind of repetitive, but in order to complete the proof properly, you need to have each one of these in here. And finally, because we know that angle B is a right angle, we then say that angle or line 1 is perpendicular to line 3 because definition of perpendicular lines. It's a definition of perpendicular lines because perpendicular lines creates an angle of 90 degrees.